Okay, so for this example, we're going to calculate the hypotenuse of a right triangle using the functions POW and SQRT in our user-defined function getHypo. Now, notice that in the prototype for getHypo, it simply takes two floats and returns a float. Notice it's empty right now. I haven't written up the formula, but I will in a minute. So what we're going to do is we're going to collect the base and height in main and then store it in result and print that result. So before we actually populate result, we're going to have to define how that function getHypo works so it can actually store something meaningful, right? So we're going to have a return statement here. And what we're going to do is SQRT, square root of base square plus height square. So notice here, I'm just going to open and close the parentheses, put a semicolon, and this is where I'm going to square the base. So POW of base, comma, 2, plus POW of height, comma, 2. Okay? So this allows us to square each element within square root. So basic Pythagorean theorem. So now we can assign result equals that function called getHypo and supply it with your base and the height, which are local variables within main, and then we can print our result. So printf the hypotenuse equals %.2f slash n, and that would be the result right here. All right, so the lesson out of this is you can have math functions within other math functions, right? So nested into them. So if you had a square root of x squared plus y squared, this is a typical good response for that, okay? All right, well, let's see how the result looks like. So compile and run. And let's say the base was 1 and the height was 1. So we know that would be square root of 2, right? 1 squared plus 1 squared is square root of 2, which is 1.41. Okay, good. Notice it ran really fast because my system pause is missing. So let's go ahead and do that. So we can actually hold the screen for a second. So compile and run. Let's do the same example. Enter 1 and 1. And there you have it. Now you can enter more other values other than 1 and 1. So for example, 2.3 could be a valid value, 7.8. And there you have it. The hypotenuse is going to be it's going to be the longest side of the triangle, right? So, and notice it's closer to the height than the base, since the base is very narrow. Okay, and it's very tall, as you know, based on these values. Okay, we can have a lot of fun with this by making the base as small as possible. So let me just run here. So 0.01, and make the height as tall as possible, 2.3. Let's see what happens. And it's getting really, really close to it. It's not really equal, but it's got really close. So you basically have a vertical line, okay? Almost, with a slight angle in there for that triangle. So it's very squished up triangle. So it's a lot of fun. So if you want to make a triangle that has two equal sides, like the 1 and 1, then that's square root of 2, right? Okay. Let's do one that has 4 and 4, right? So let's go ahead and run. 4 and 4. Okay, so 4 squared and 4 squared. So, right? So what's going to happen? 4 times 4 is 16. 16, 2 times 16, and then square root of 2 times 16, which is really 4 square root of 2.